Alright, so for number 1 here, they want you to solve by finding square roots. So 9x squared equals 25. We want to isolate x if we can, so we can do that. So let's just divide by 9. 25 ninths. We can't simplify that. But we did isolate x here, so let's just take the square root of both sides. So x equals positive or negative. The square root of 25 ninths is 5/3. If you want to write it in set notation, it would be negative 5/3, comma 5/3. I want you to solve this equation. First, check to see if this over here is a perfect square trinomial. So the square root of this is 2x, the square root of that is 1. If I multiply those two together and double it, I do get 4x. So I'm going to write it as a perfect square trinomial. 2x goes here. I take this sign, put the 1 here. So now I'm going to take the square root of both sides. So I have 2x plus 1 equals positive or negative. Square root of 49 is 7. So I'm going to subtract 1. And then I'm going to divide by 2. So x equals positive or negative 7 minus 1 divided by 2. So let's do the positive 7 root. Positive 7 minus 1 is 6. 6 divided by 2 is 3. That's one option. Now for the negative 7 minus 1 is negative 8. Negative 8 divided by 2 is negative 4. So these are our solutions. Complete the square. What we want to do is take half of this term and square it. So you get 9/4. Number 4, they want you to solve this by completing the square. First off, let's just move everything to one side. So let's subtract x from both sides, and let's add 1 to both sides. Let me just move this down a little bit. So negative 3x minus x is negative 4x. Then you have the positive 1. So they want you to complete the square, so move the constant term over. I left a space here so that we can complete the square. We don't have to factor out the leading coefficient since the leading coefficient is 1. So I take half of this, that's negative 2, and I square it, so then I add 4. Because I added 4 here, I have to add 4 here. This is now a perfect square trinomial. It's x minus the square root of this is 2. This becomes 3. So let's solve now. Take the square root of both sides. So you get x minus 2 equals positive or negative square root of 3. Now we just add 2 over. So 2 plus or minus the square root of 3 is your answer. Alright, number 5, we're going to do the same thing as the last one. So let's add the constant over. We're going to factor out the lead coefficient on the left. So 10 divided by 4 is 10/4 or 5/2. Now we're going to complete the square here. So 1/2 of 5/2 is 5/4, and then you want to square that. That becomes 25/16. So let's add 25/16 inside here. But you're really not adding 25/16. You're adding 4 times 25/16. So what is 4 times 25/16? The 4 and 16 can cancel. So we have 25/4. So what I'm going to do is I'm going to add 25/4 over here. So let's simplify. So 4, this is now a perfect square trinomial because we created that. So we have x plus the square root of this, which is 5/4. This over here is going to be 37/4 because if I make this fourths, it becomes 12/4. 12/4 plus 25/4 is 37/4. So let's now solve. So we are going to divide by 4 first. So we're going to have x plus 5/4 squared equals. When I divide a fraction by a fraction, what I'm going to do is take the top fraction and multiply it by the reciprocal of the denominator, or the bottom fraction. So I'm going to have 37/16. Got some crazy numbers here. Alright, now we're going to take the square root of both sides. So we have x plus 5/4 equals positive or negative square root of 37/16. Now, what we can do with the square root of a fraction is we can recall that the square root of a fraction is the same as the square root of the numerator divided by the square root of the denominator. So if I split up square root of 37/16, I'll get the square root of 37 over the square root of 16, which is positive or negative square root of 37 over 4, since the square root of 16 is 4. So if I have positive negative root 37 over 4, and I subtract 5/4 from that, because all of these fractions have the same denominator, I'm just going to write it as one denominator. It's all over 4. And then I'm just going to write what I have in my numerator. -5 plus or minus root 37. And this is my answer right here. This problem had some ugly numbers in it. But if you remember some basic rules with working with radicals from Algebra 1, it will help you out. Number 6, rewrite the equation in vertex form. So let's start with the original problem. The first step is going to be moving the constant. Next, we're going to factor out the lead coefficient. So this is going to be -5x divided by -4 is positive 5/4 x. I'm going to leave a space here. Got a little carried away with my parentheses here. So now I'm going to fill the space with half of 5/4. So 5/4 times a half is 5/8. squared. That's 25/64. But I'm not really adding 25/64. I'm adding -4 times that. What is -4 times that? So if I do that, the 4 and the 64 cancel. So then I end up with -25/16. So really what I'm doing is I'm subtracting 25/16. Because when you multiply -4 by 25/64, you get -25/16. So in order to add these, I have to get common denominators. So -3/1 minus 25/16. I'm going to get 16ths here. 1 times 1 goes into 16 times. So I have to multiply 3 by 16. So that's going to give me -48. Again, we have some ugly numbers. 48 and 25 is 73. So we're going to have y minus 73/16 equals -4 times. This is a perfect square trinomial now. Again, I got carried away with my parentheses. X plus square root of this, which is 5/8. And they want you to find the vertex. It's going to be the opposite of this, -5/8, comma, the opposite of this, 73/16. So these are your two answers. Number 7, solve by factoring. So it's in order. The lead term is positive. This is not a perfect square trinomial, so we're going to use the box method. So the 2x squared goes here. The 1 goes there. 2 times 1 is 2. The only possibility is 1 times 2. You're going to have the same sign. Both are negative. So we're going to have -1x and -2x. So let's put the signs around. Negative, positive, positive, negative. We have a 1 here, x here, 2x here, and a 1 there. So 2x minus 1 times x minus 1 equals 0. Now to solve, we'll set each of these up equal to 0. If I set 2x minus 1 equal to 0, I add 1 and I divide by 2. I get x is 1/2. If I set x minus 1 up equaling to 0, I add 1, I get x equals 1. So my solutions are 1/2 and 1. Alright, number 8. We want to plot these points and see if they are collinear. So -4, 3 is right here. -3, 3 is here. And -2, 4 is there. So they're not collinear. So let's get the calculator out. Let's do stat edit. Let's clear out our old numbers, if you have any. And enter the L1. So -4, -3, -2. L2 is going to be 3, 3, and 4. Hit stat, calc, 5, enter. So 0.5, 3.5, and 9. So a 0.5, 3.5, and 9. So our function is going to be f of x equals, you could do 0.5 x squared plus 3.5 x plus 9. And that's your function. Number 9, let's get the calculator out again. Clear out any equations that you might have had. A shoe is being thrown from a height of 5 feet, and there's your equation. So let's plot that. So negative 0.84 x squared plus 5 graph. So this is where you're standing, 5 feet out, up, and you throw it and it goes all the way down and it hits the ground here. How many feet away is the 0 right over here? So second, trace 2, left bound is anywhere before it, right bound anywhere after, and then guess. So it's going to be approximately 2.44 feet. So roughly 2.44 feet away. Number 10, what is the domain for the one we just did? Why is the domain what it is? Well, the domain for this problem, and if you remember what it looked like this, kind of, right? Whoops. Something like that. The area that we're going to concentrate on is from here to here. And the reason why is because this is where you're standing. You're standing at 0 feet and a height of 5 feet. And you throw the shoe and it lands. Well, this part is under the ground. This part is under the ground, and this part is a negative distance. So none of this is going to be part of the domain, and none of this is going to be part of the domain. The domain is from here to here. So the domain is going to be the set of all x's such that x is greater than or equal to 0, but less than or equal, I have to go back to see what it was, 2.44. 2.44. And why is it that way? Because we kind of just explained it. It has to be greater than or equal to 0 because you can't be you can't have a negative distance, and it has to be less than or equal to 2.44 because that's where the shoe lands, and you can't have a negative height, and that's the reason.